This video is on array creation. The first method to create an array is explicitly from a list of values. So, let us consider that we have a list, say, named as confirmed, which has got values as 10, 12, 15, 17, and 21. In order to create an ND array from the list or from any other method, we first need to import NumPy package. For this, we use the statement as import NumPy as NP. This NP word can be anything else also, but by convention, we write it as NP. After importing NumPy, we are in a position to use all the functions defined in NumPy library. In order to create a one-dimensional array from a list, we will use the array function of the NumPy array. How do we call it? By np.array. We write the word np followed by dot operator, and whatever function we require, we call that function. Here we call the function array with one parameter value which is confirmed, that is the list. So we pass the list as a parameter to the function array, which is a function of NumPy library. What we get is a one-dimensional array which we have named as confirmed cases. So the name of the list is confirmed and the array created from this list is confirmed cases. Let's move further. To find out what is the difference between a list and an array, what we do is here we try to print the list and its type. That is, by using the print statement, we first display the list confirmed and then we display the data type of confirmed by using the input function type. And we are giving the confirmed as a parameter to type. What we get here is the output that list of confirmed cases is a comma separated list, which is enclosed in square brackets. And the data type of confirmed is a class list. That is, it is an object of the class list. Now, let us try to print the data type of the array which we have created. So we first print the array confirmed cases and we print type of confirmed cases. Here what we get is, look at the second last line of the output. The one-dimensional array of confirmed cases is again a list of elements which is enclosed in square brackets, but there is no comma in between as there was in the case of list. And the data type is class numpy.nd array. That means confirmed cases is a nd array which has been created by using numpy. So this is the basic difference between an array and the list. Kindly note that the absence of comma is the fact which shows that it is an array and not a list. Moving further. Now, see, here we can create one-dimensional arrays. One-dimensional arrays are of two types. Either it can be a row vector or it can be a column vector. When we have to create a row vector, we will simply pass the list of values in the array function as we have done in the second sentence here. So cured cases January is equals to np.array, where we are passing the list of values as an argument to the function array. Further, we create vector as a column. In this case, instead of giving the values as the list, we give lists inside the array function, where each list consists of one element. You can see here, this is a nested list with one element in each list. First list consists of only one element 20. Second list consists of one element 50. Likewise, the other two lists. When we display these two vectors, we see that the first is a row vector and the second is the column vector. The row vector denotes cured cases in January and the column vector denotes the death cases in the month of January. So this is the basic difference between a row vector and a column vector, that column vector के लिए we need to specify nested list with one element in each list as an argument to the function array of NumPy array. Moving further, let us now move our discussion to a three-dimensional matrix. We can create n-dimensional matrices with NumPy array function. Now, we have here three lists. First list is named as cured cases in March. Second is death cases in March. Last is confirmed cases in the month of March. We call again the array function by np.array, and in the bracket, instead of supplying only one list, we supply three different lists as parameters. What we get is matrix 1. When we print it, we get a three-dimensional matrix where each row is the individual list which we have passed in the array function. Moving further, let us talk about some of the properties of the n-dimensional matrices. We are still using matrix 1, which we used in the previous slide. When we do matrix 1.shape, it displays number of rows and columns as a tuple. That is 3, 4, which says number of rows in matrix 1 are 3, number of columns in matrix 1 is 4. Matrix.size tells us the number of elements, that is 12, which is precisely 3 into 4. Matrix.ndim says number of axes, that is, it is a two-dimensional matrix, so it will give you 2. When you use the function type and you give in bracket matrix 1, this will tell you the data type of the matrix, that is class numpy.ndArray. But when you do matrix 1.dtype, this will give you the data type of the data which is stored in the matrix. Here in this matrix, all the values were integer. So you are getting it as int 64. Next, you have matrix 1.item size. It gives you the size of each item which will be occupied in the memory. The integer int64 says that each array item will have 64 by 8, that is equals to 8 bytes in memory. So the item size comes out to be 8. Moving further, let us again understand the shape vector, the shape property here. In the case of a one-dimensional array, it will return you, shape will return you a tuple with value 9, which says that in the first row, there is only one row and the number of elements in it are 9. If you talk about a two-dimensional matrix, then two-dimensional array or a matrix, then it will return you shape as 3, 5, which says the number of rows are 3 and the number of columns are 5. And so on for an n-dimensional matrix. Suppose if you talk about this n-dimensional matrix, then it will tell you again the number of rows, the number of columns, the total number of dimensions here. That is, here there we can see 4 types of such matrices. So it is returning you 4. Now, let us move on our discussion to another method in which we can create a matrix. Instead of using the array function, now we use the function arrange. We write np.arrange, that is range of values, which takes 3 parameters: start, stop, and step. Here in this example, we have kept start equals to 1, stop equals to 10, and step equals to 3. The output which we get here is the array A, which has values 1, 4, and 7. Now, how do we get this array? Here, the start value is 1. Therefore, the first element will be 1. Now, the step size is 3. So, the next element will be 1 plus 3, that is 4, which is lesser than stop. Then, third value will be 4 plus 3, which is 7. That is again less than stop. Then the next value in this pattern would be 7 plus 3, that is 10, which is equals to stop. So here we will stop here because the stop value is exclusive. So the array which is generated by arrange function is 1, 4, 7. Moving further, let us consider few more examples with arrange. If we write np.arrange and in bracket we give only 10, then it implicitly says that the start value is from 0, the step value is implicitly 1, and the stop value is 10. So you will get range of numbers starting from 0 to 9, excluding the stop value. Even this works with the negative values. If you give the values as start value as -8, -2 as stop value, and step size as 2, then in that case, first element will be -8. Next element will be -8 plus 2, that is -6. Next element will be -6 plus 2, that is -4. The fourth element will be -4 plus 2, that is -2, which is again the stop value. So we will not have the fourth value and the matrix will have values -8, -6, and -4 in it. Now, moving further. Next method is zero initialized. We can create an array with all elements initialized to 0 using the function zeros. By default, the data type of the array created by zeros function is float. The following code will create an array with 3 rows and 4 columns in each element set to 0. So here you have np.zeros 3, 4. So you have now here 3 rows and 4 columns with each element set to 0.0. Likewise, you have one initialized function where the function is np.once. If you write it as 5, 3, so it will give you 5 rows with 3 columns and each element equal to 1.0. Another method is the diagonal values. Here you have a function called identity. When you give identity and in bracket you give 3, it means that it will create an identity matrix 3 cross 3. That is, the diagonal elements will be 1, non-diagonal elements will be 0. The same thing can be obtained by I function. Now let us talk about another function which is called as diag. When you give diag, when you give the values as 1, 2, 3 and 4, it will give you an array where the diagonal elements will be 1, 2, 3 and 4. But if you see that each element here is a list. The first list will have values 1 followed by 3 zeros. The second list will have value 0, 2 followed by 2 zeros. The third list will be again 2 zeros, 3 and 0. The last will be 3 zeros followed by 4. Now it's your time to start and create arrays with all these different methods. Thank you.